Welcome all. Welcome to the second seminar of Digital Architectural Design Studio that we run with Professor Birgül Çolakoğlu. This subject of this term is circularity in urban environments and digital platforms. Today we have a very important guest, Professor Duygu Erten from University of California, Los Angeles. Unfortunately, she is not able to join to this session because of her sudden change in the schedule. However, she sent us a video of her presentation. Please let me introduce her briefly. Dr. Erten is a graduate of Boğaziçi University where she earned her Bachelor of Science degree in Civil Engineering. She earned later a Master of Science degrees and PhD degrees in Civil and Environmental Engineering from Rutgers University. She worked as research fellow at Princeton University. Additionally, she worked as a project manager in managing large-scale, complex projects for multinational firms in the US. She represented Turkey on the lead international roundtable of US Green Building Council until 2017. She has published numerous papers and received important awards, including that she's the recipient of the 10 Most Powerful Women in Sustainability Leadership Award in 2017. The title of her presentation is Circular Economy Approaches in Post-Earthquake Waste Management System. Please join me welcoming her. And the screen is yours, Professor.
Okay, I received share Duygu Erten's presentation, and after finishing, she encouraged us to discuss the subjects and list the questions that are raised. So when she is back or in some other online meeting, she will join us. So
hopefully.
Hopefully, yeah. Video klipi oynatmıyor. Bakalım oynatacak mı? Can you see it?
Yes, we see the screen. Seems 34 minutes.
Okay, so I will just click. Hopefully it will run.
Thanks to Circularity and Urban Environment Digital Platform for inviting me to give a talk on circular economy approaches in post-earthquake waste management system. I'm an independent researcher working on construction and demolition waste and green buildings. The topic is gaining more and more importance due to recent earthquakes because this is a very important topic for health and other issues. My talk today will cover 5 sections, the principles of circular economy, construction and demolition waste. I will introduce the European framework levels and how we can use it for circular approaches, post-disaster waste, and circular economy approaches, the earthquake waste management system. As we all know, circular economy is based on 3 principles: keeping products and materials in use, designing out waste and pollution, and regenerate the natural systems. We all know that recycling still matters, and there are many circular economy approaches to actually improve the value of your brand and products. Keeping products and materials in use is probably the most important part. Circulating products and materials means keeping them in use at their highest value. It avoids the costs of extracting and creating materials and of disposing waste. A circular product is one that consumers can use for as long as possible. When the product wears out, its parts can be reused or the product remanufactured, remade. At the end of the product's life, its raw materials can be fully recycled. The second principle is designing out waste and pollution. Circular economy sees waste as a design flaw and that causes us to use more resources than we need. Overusing resources results in volatile prices, shortages, and ecological damage. By designing out waste, circular economy lets businesses create value without using up finite resources. Third is circular economy supports natural processes and lets nature flourish. Circular economy encourages regenerative systems as well as economic gains. Positive side effects including regenerating soil, well-managed water resources, and thriving biodiversity. Recycling begins at a product's end of life, and circular economy focuses on the beginning of life. It prevents waste from being created in the first place. About 80% of the environmental impact of a product is locked when it's designed. Creating circular products involves changing the way we choose materials and design, produce, and distribute products. I came across an incredible material which people here in Los Angeles used it for thermal insulation. It's called green cell foam. You can compost it, you can dissolve it in water, and you can burn the foam panels. It's an amazing new construction material. As you see here, incorporation of circular economy approaches in construction and demolition waste systems promotes transition towards the recycling of construction and demolition waste, reducing stress on natural resources, lowers greenhouse gas emissions, and improves the job opportunities, as you can see from this graph created by Sharma. And it aligns with sustainable development goals, which we have to fulfill until 2030 and 2050. Global construction and demolition waste recycling market is blooming. All over the place, the market is expected to reach close to $150 billion. Yes, $150 billion by 2027. This is a growing market with lots of job opportunities. Sustainable waste management is an important part of any green business strategy and also circular economy strategies. All over the world, there's a lot of work to ensure that hazardous waste is handled in the safest way possible. I'm a member of International Solid Waste Association, and they work quite hard on that. The EU's Waste Framework Directive expects member states to recycle 50% of municipal waste and 70% of construction waste. The European Commission has adopted the Circular Economy Action Plan under the European Green Deal. This plan promotes sustainable consumption so that the resources used kept in the economy for as long as possible. In Turkey, until 2030, government put 40% recycling rate for construction waste. So I would like to talk European circular construction approach today, because in Turkey, we follow Europe closely. We follow their directives. As you all know, Circular Economy Action Plan was launched thanks in 2021. And since then, there's a lot of action going on, which I like a lot. EU put out a levels framework. They have been working on this since 6-7 years. It's a framework for improving the sustainability of buildings, incorporating resource efficiency and circular economy principles. It aims to make it easier to integrate life cycle assessment into public projects. Levels is not a certification system. It's not competing with DGNB, LEED, BRAM, STR, etc. But Levels is a framework creating KPIs that all certification systems have to align. And Europe is going from a voluntary mode to a mandatory mode because we have to be quick. We don't have much time. Greater London Authority, for example, they updated the London plan, and they require referable developments to submit a circular economy statement detailing plans for handling waste and how components will be disassembled for reuse at the end of the building's life. Italy, for example, they require all public construction projects comply with green public procurement minimum environmental criteria, which includes targets from use of recycled or recovered materials and materials reuse at the end of life. The Netherlands government has set a time frame to transition to a full circular economy by 2050, with a milestone target of reducing virgin raw material use by 50% by 2030. So everyone is pretty ambitious. So Turkey has to set its own goals. Levels provides a simple and accessible entry point to circularity and life cycle thinking. Here on this slide, I'm interested with number 2 specifically. What is that? Resource efficient plus circular material life cycles. If I open that section, that includes bill of quantities, materials, and lifespans. And we have unit quantities, mass plus years. Construction and demolition waste material, the unit is kilogram of waste, materials per meter square, total useful area, and design for adaptability and renovation. There is an adaptability score you get out, and design for deconstruction, reuse, and recycling, that you come up with a deconstruction score. In construction and demolition industry, through the help of levels, we start talking with metrics. I like indicator 2.2 because it concerns construction waste management, and level uses European Construction Demolition Waste Management Guide published in 2018. While examining the chemical components of materials, for example, in more detail, LEED complies with ANSI BIFMA standards and ASTM standards and Safe Drinking Water Act standards. BREEAM, different waste components are thoroughly investigated by different standards. For example, EN 13055 for coarse aggregate. In German system DGNB, using standard building components and EU biocides regulation, they help smooth the process of recovering and recycling construction and demolition waste. For projects that cannot meet essential requirements related to the recyclability and reusability of products, it's mandatory to go along with European Directive and Directive 2000, again put out by European Union. What helps us with circularity? Definitely the bill of materials. That is primarily built to support the following indicators in the most beneficial way: life cycle, global warming potential, construction and demolition waste estimates, and life cycle costing. It separates the materials, glass, concrete, brick, steel, etc., that are the main components of the building, and provides part of the life cycle analysis and cost analysis inventory, as well as estimates for construction and demolition waste. We have 3 sections when we are analyzing construction and demolition waste and material concepts. First, we segregate. That is the first step. And we recycle the ones we can and reuse the portion that is left out. There are 6 main concepts in construction and demolition waste according to the levels framework. These are setting relevant targets or key performance indicators, KPIs, pre-demolition auditing, if there is a demolition taking place, outlining the waste management plan. This is also important during the construction, of course, but for construction and demolition waste, the most important part. The influence of project type on construction demolition waste generation and management, good construction practices, which we get a lot of inspiration from green building certification systems. Their credits related to good construction practices, especially BREEAMs, are very helpful. And buildings as material banks, the bump principles. So level sits on 6 main concepts in construction and demolition waste. I like this slide because treatment flow of disaster waste after the Japanese earthquakes put together by Tabata gives us quite a bit of light on how to manage the disaster waste. This is from a disaster waste management plan prepared by Kumamoto government. As we all know, wood, concrete, tiles, ceramic, glass, gypsum board, metal scrap, these are the first ones that we separate, the easy ones. And then there's, of course, miscellaneous waste, especially from dwellings, like in Turkey earthquake, so many dwellings collapse. There are lots of home appliances there. And then again, miscellaneous waste, unfortunately this time, including animal and human waste. So it all goes to recycling after certain processes, but storage, separation, using crushers, and trying not to send anything to landfill is the trick here. According to Greenpeace, I got this slide from their site, there is a serious amount of waste from the recent Turkey earthquakes, over 100 million tons. Even the magnitude 9 Japan earthquake created 29 million tons. You know, we lost 11 cities basically, and this is expectable. Earthquakes, depending on their magnitude, epicenter location, local construction characteristics, and many other features, earthquakes may generate large amounts of debris and waste. The large amounts of debris generated after the disaster become one of the main problems of people facing health issues and the need to reconstruct the city. Proper characterization and quantification of debris, subsequent waste management, and reconstruction planning are essential for the restoration of an area affected by an earthquake. Torres and his researchers developed a methodological approach to characterize, quantify, and forecast the debris produced as a consequence of earthquakes, as well as the flow of materials required for the reconstruction of the area affected. The proposed methodology includes a residential infrastructure characterization stage, a probabilistic estimation of damage by characterizing the vulnerability functions using CAPRA-GIS tool, and material flow analysis for the characterization and quantification of debris associated with the event of an earthquake, and for new materials for the reconstruction stage. Well, they created a debris and risk map with forecasting. It helps identifying the most damaged areas, dwellings, to prioritize for urgent reconstruction, and allows for establishment of effective delivery routes for new construction materials. This method helps to estimate the amount of new materials required in the reconstruction phase and inform governments whether the affected area has sufficient capacity to supply materials from domestic sources. Furthermore, it's possible to designate areas for landfills, as well as possible debris treatment plants and recycling or reuse procedures in the end-of-life stage. Moreover, their methodology was applied to a case study, and they got satisfactory results. High amounts of clay, steel, and concrete were found in the material stock of the studied location, as well as the debris generated. In the highest seismic scenario, 200,000 tons of concrete, 7,400 tons of steel, and close to 500,000 tons of clay brick from in the residential sector were transferred into debris. Also, the most affected dwellings and areas identified in georeference map and the MFA provided an estimation of flows based on selected end-of-life options and regional import of materials for the reconstruction phase. In Turkey, we can create a similar study for different sections of Istanbul, for example. And accordingly, we can plan allocating empty spaces for post-earthquake construction and demolition waste arrangements. Another study is by Amoto, assessed different stages, strategies of waste management, estimating the carbon footprint and the economic impact in order to define the best choices. We can have the best circular approaches, but if it's going to cost us 10,000 more than a standard procedure, then it's not feasible. Overall, different management options can be applied that have different costs and impacts on the environment. A temporary storage site could be used, rubbles can be treated through different technologies, and the treatment can be carried out at different distances from the site of the event. The environmental impact assessment evidenced the importance of an in situ pretreatment of rubbles and of an enhanced refining addressed at the achievements of high quality inert. On the other hand, the economic analysis carry out a simple treatment of the rubbles. Consequently, their assessment resulted in conflicting conclusions where an enhanced treatment of the rubbles is positive from an environmental point of view, but negative for the increase of management costs. So cost is something we always have to watch out. The economic criteria are currently pushing any decision taken by the emergency managers. However, the environmental load may have a long-term effect with even more significant economic consequences, and it cannot be neglected. Another framework developed helps to provide waste management with operational keys to prevent post-natural disaster waste and to manage it. It was intended to help stakeholders to avoid health and environmental risks and return to normal conditions as soon as possible. The quality and amount of waste can be estimated by studying technical documentation for manufacturing and building materials, knowledge on the territory, like field surveys. The information collected will allow implementing waste prevention actions, dimensioning temporary storage sites for treating post-disaster waste, organizing collection, and anticipating the possibilities of sorting. As you can all see, creating land areas, empty land areas are so important. We have to, like the forests not burning, we have to create roads. In the cities, we need space. We need lots of space. Here is another study by Dinot, creating 3 types of post-disaster waste assembly: electronic waste, hazardous waste, waste furniture, non-hazardous waste, and harmless wood and green waste. Okay? Waste storage areas obtained by clearing roads. Roads will be cleared in order to get the traffic moving again. Waste will be stored close to traffic lanes in sealed areas. Thank God, in latest Turkey earthquakes, highways and roads performed quite well compared to buildings. Repositories of post-disaster waste organized spontaneously by the population affected. These areas are rapidly implemented to maintain control of flows, risks, and facilitate the evacuation of spontaneous contributions. Areas used to implement initial waste sorting. Temporary waste treatment sites are necessary to prevent environmental dispersion and limit the onset or spread of health and environmental risks related to uncontrolled storage. An example of temporary waste treatment site organization given here can be used easily. And some examples of actions of prevention, limiting the amount of waste. Of course, this is quite important, like fixing or storing objects in a closed shelter to prevent their spread. Avoiding contamination. Unfortunately, it looks like it is happening in latest Turkey earthquakes. There has been a lot of asbestos talk recently. Avoiding waste mixtures, setting up separate collection, identifying hazardous products by using waterproof labels with the risk pictograms, and reducing the harmfulness of waste and limiting the spread of waste. Very important. Not putting all this waste in a landfill, cover it, and, put lime in it. That is not the right approach. Organization is key after the earthquake for all the stuff that I summarized, because inhabitants first must be informed of the organization of the post-disaster management, information on the preventive action to be implemented, sorting of waste to be shipped, and the location of areas for grouping post-disaster waste. Unfortunately, because majority of the buildings were residential, people have valuables. People who survived want to get their valuables from this post-disaster waste. Waste storage areas, monitoring and controlling waste must be established. Once the waste has been transferred to recycling plants and waste dumps, it's necessary to rehabilitate the post-disaster waste storage areas. To ensure the transparency and traceability of waste and improve existing practices, a comprehensive report of waste management is carried out. And the data collected enables to compare theoretical and real waste qualities and quantities, calculate recovery and disposal rates for each type of waste, calculate the real costs of managing collection, transport, storage, dispatching waste to recycling plants and waste dumps, and identify malfunctions, propose paths for improvement. Disaster waste management has no durable, sustainable business model for the team of government regulator and cleanup contractor. From all the research I conducted, all the literature search, as noted by Ibrahim, Kirk, Kugli, and many others, contractors may not be aware of the business potential that lies within the reclaimed materials. So creating awareness is the #1 role NGOs, should have. Check out this disaster area mixed waste, a graph. Again, without registered procedures, waste in, waste out, there are a lot of valuable recyclables that can be handled without registered procedures or work logs. Mexico earthquake, again, created a big disaster, and according to Padilla and Engels, they created a methodological framework for developing countries, which may help in our case, which allows us to move from reactive actions made in response to an earthquake to temporary strategies that allow the removal of waste to be sent to possible recyclable processing centers in accordance with current regulations in Turkey. But I don't even know if there are recyclable processing centers in these 11 cities. Based on the importance of analyzing the different waste from collapsed buildings, rubble, and domestic waste, the authors made the estimations always separating these two elements, since it's considered that the union of these different types of waste makes waste recycling planning very difficult. In terms of the capacity installed to earthquake waste management after 2017 earthquake in Mexico, based on their findings, it's possible to conclude that recyclable processing companies in Mexico dedicated to rubble, white goods, biodegradable waste, and metals, they have a reception and processing capacity above 100% of the estimated earthquake waste. After the triple disaster of the 2011 Tohoku earthquake, and they had tsunami afterwards, that cascaded a serious disaster at a nuclear power plant at Fukushima. That's why we should not be having nuclear power plants in earthquake zones and in countries that are prone to earthquake. The government worked with scientists to create a manual to reuse and recycle all the commingled debris, even the radioactive materials, for safe handling and to ensure they don't take up precious space for waste landfills. Natural disaster extent is difficult to estimate. Who would say what happened in Turkey today would happen? Waste management is often overlooked. Feedback on recent natural disasters has shown the importance of the issues related to management of post-natural disaster waste. Large amounts of waste must be managed quickly to restore road communications and local economy, return for normality as soon as possible, and control health and environmental risks. Thus, the authorities responsible for organizing the management of post-natural disaster waste require methodological and operational tools to prevent production of waste and anticipate its collection, transport, and treatment according to the goals of waste management policies. These tools must allow controlling. It is critical to control the scattering of harmful asbestos fibers during a rescue and recovery mission after a building collapses, as the scattered dust is harmful to workers and residents. Another study conducted by Kim, the amount of asbestos fibers that can be generated by scattering secondarily in a post-disaster situation was measured over time. The scattering of asbestos fibers can be suppressed, and the concentration of asbestos fibers in the air can be reduced by spraying water or asbestos stabilizer onto the surface of broken ACRS. Furthermore, field workers should be given orientation for asbestos dust. Finally, during rescue operations, workers must wear dust-free coveralls and other protective equipment, including a mask attached with a HEPA filter, and sanitary facilities should be provided to minimize the damage from asbestos and harmful dust. Meanwhile, disaster control towers should take measures to improve the disaster contamination control program, considering the facts mentioned above. The results of their study are applicable not only in developed countries in which asbestos is widely used, but also in developing countries. The last but not the least, there are lots of conclusions we can derive from what happened, but it's time for the demolition industry in Turkey to quickly find ways to keep construction waste in use at a capacity projected for a large-scale disaster in which the volume of incoming debris sources will exceed normal operational parameters. In each disaster zone in Turkey, the newly established environmental agency, like EPA of America, in Turkey, Turkish Environmental Agency can serve as a focal point for economic activity and material centers by establishing recycling platforms. The rapid adoption of circular principles in the world of construction and demolition waste will enable greater flexibility in material operations, shorter distances in logistics, and flexible flow of resources in situations where access to international resources or is isolated from excess disruptions. And we all know there's a law in Turkey, 6,306, the transformation of areas under disaster risk. It was adopted in 2012. And this law aims to minimize the loss of life in earthquakes by taking the necessary measures regarding the structures that are inside or outside the risk area and have completed their economic life or are determined on the basis of scientific and technical data to be at risk of collapse or severe damage. And the law points out the necessity of demolishing these areas identified after the identification of risky areas. Guess what? After these earthquakes in Istanbul, we are expecting one. The possibility is very high. We should start immediately demolishing. Unfortunately, I'm not able to say retrofitting. I wish I could, but the quality of construction, shoddy construction, is pushing us to demolish. We have to create construction demolition waste management plans with circularity principles and immediately get advantage, economic advantage, environmental advantage, job creation advantage of this law. Look at all these wonderful areas created. These are from Europe and United States. You can bring the post-construction earthquake construction and demolition waste here, and you can do wonderful reusing, repurposing from all the waste. But again, you need space, you need organization, you need management. And every municipality in Turkey should have large areas containing these containers, all sizes, easy to move, trucks that can carry them around. Look at this picture. These are from a burnt house in an earthquake. To the right, it's burnt wood, and it's used for a new house. It's a beautiful house that used lots of, old wood stuff. The construction and demolition industry is cost-conscious mover in every aspect of city, regional, and national responses to a declared disaster, unfortunately. Continuous innovations in manufacturing and remanufacturing research and technology are already coming online across the waste management industry. So adopting them into the construction demolition ecosystem is a perfect application of the principles of the circular economy. A recent PhD thesis conducted by Andrews concludes that education in the processes and business model innovations will be the key enabler across the spectrum of operations for both government regulators like the emergency managers and the demolition business planners and operators. Finally, I like to conclude with a building from Denmark. You can eat this building, basically. All recycled materials, reused materials, FSC certified wood, lightweight. This is exactly what we need in Turkey. And not high rises which do not use the right products because of the cost, but horizontal developments. Let's not forget what a waste that's used to express a feeling of regret when something is put to waste without deriving its value. I wish in Turkey the buildings collapsed did not have all these mirrors, extra wardrobes falling on the beds, and lots of stuff that should not be there, really. We can do so much with circular approaches in order to prevent losing human lives for future earthquakes. Thank you for inviting me. Unfortunately, I won't be able to attend the discussion session because I have another engagement at ULI Los Angeles, which overlapped with this assignment. Have a wonderful discussion session. And again, thank you for inviting me for this valuable talk. Thank you. Bye-bye.
Thank you very much, Professor Erten, for her enlightening presentation. Please share your questions with us. You may email us, and we will be sharing your comments and questions with Professor Erten. Thanks for your valuable participation to this session. And I think we will close this session. Thanks.